See the moon landing as they did in 1969-11. Sign up for CNN's Wonder Theory Science newsletter. Explore the universe with news on fascinating discoveries, scientific advancements and more. CNN, nearly 50 years after it was collected, a lunar sample from the Apollo 17 mission has finally been opened at NASA's Johnson Space Center in Houston. It's one of the last unopened samples from the final Apollo mission to land humans on the moon. We have had an opportunity to open up this incredibly precious sample that's been saved for 50 years under vacuum, and we finally get to see what treasures are held within, said Thomas Zurbuchen, Associate Administrator of NASA's Science Mission Directorate in Washington, in a statement. NASA just opened an untouched moon rock sample. It was collected by NASA astronauts Eugene Cernan and Harrison Jack Schmitt in December 1972 when they hammered 14-inch, 36-centimeter, cylindrical drive tubes into a landslide deposit in the Taurus Littrow Valley. The two astronauts vacuum-sealed the tube while still on the lunar surface. Once the mission returned to Earth, the captured sample was stored in a second protective tube in a special cabinet at Johnson's Lunar Laboratory, where it remained undisturbed until this week. The sample, known as 73001, contains lunar soil and rock fragments that can provide scientists with a historical record of the moon's geology. Another sample from Apollo 17 was opened for the first time in 2019, during the 50th anniversary of the first lunar landing. Sample holdout for future tech. Some Apollo samples were purposely left unopened so that future generations with better technology could study them and unlock more information about Earth's natural satellite. We had quite a number of very good cores that are giving us new information, Schmitt said in a video shared by NASA during a Science Live episode Thursday. It was anticipated early on in the Apollo program that analytical technology would mature and become much more sophisticated with time. In fact, Apollo never ended for lunar scientists. Schmitt is a geologist, and the only civilian and scientist to ever land on the moon. The other 11 men were all considered to be active military members. Before this sample was opened, a team used X-ray CT technology to scan 3D images of the sample inside the tube at the University of Texas at Austin. This is a close-up of the Apollo 17 lunar core sample 73001 being taken out of its drive tube for the first time since it was collected 50 years ago. This will be the permanent record of what the material inside the core looks like before it got pushed out and divided into half-centimeter increments, said Ryan Ziegler, Apollo sample curator, in a statement. The drive tube was very full, which is one of the things we learned with the CT scans, and it caused a slight complication in how we were initially planning to extrude it, but we have been able to adapt using these scans. In February, the team carefully opened the outer tube to collect any gas that may be present. We have extracted gas out of this core, and we hope that will help scientists when they're trying to understand the lunar gas signature by looking at the differential samples taken for chemical analysis, Ziegler said. An X-ray computed tomography image shows what's inside the Apollo 17 core sample. Initial scans and analysis, as well as the opening of a mock core, prepared the scientists so they didn't encounter any surprises on Monday and Tuesday, when it was time to open the sample. Then they opened the tube inside a sealed glove box at NASA's Astromaterials Research and Exploration Science Division in Houston. Apollo 11 lunar samples were searched for signs of life. Arms constrained by the massive gloves of the glove box, Julianne Gross, Deputy Apollo Sample Curator, said it was a painstaking process, but one that was fully worth it. We did this step by step, trying not to lose all the tiny pieces and screws, Gross said. We are the first people who got to actually see this soil for the first time. It's just the best thing in the world. Like a kid in the candy store, right? Steps toward Artemis lunar mission. Opening this sample can prepare NASA for collecting new lunar material when they return humans to the moon later this decade through the Artemis program, named after Apollo's twin sister. The processing team, including, from left, Karis Krischer, Andrea Masi, Julianne Gross and Ryan Ziegler at NASA's Johnson Space Center, poses in front of the newly opened sample. Terrestrial samples and lunar samples are very different, so the Artemis team has already taken that into account as they design their tools, Ziegler said. They didn't start from scratch. They started with Apollo 17 and what worked really well and are moving forward from there toward Artemis. Artemis astronauts, including the first woman and the first person of color to land on the moon, will land at the lunar South Pole for the first time. Far from the familiar conditions of the lunar equator, which was visited by the Apollo astronauts, Artemis explorers will encounter dramatic lighting at the bottom off the moon, as well as frozen conditions and intriguing lunar soil. Untouched moon samples from the Apollo missions will be studied for the first time. The moon's south pole is a great place for potentially building up large deposits of what we call volatiles, substances that evaporate at normal temperatures, like water ice and carbon dioxide, said Lori Glaze, director of the Planetary Science Division at NASA headquarters, in a statement. These volatiles can give us clues about where water came from in this part of the solar system, whether from comets, asteroids, solar wind, or otherwise. The new samples collected during the Artemis program could help scientists better understand the moon's evolution. We have an opportunity to address some really important questions about the moon by learning from what has been recorded and preserved in the regolith rocky soil of these Apollo samples, said NASA Astromaterials curator Francis McCubbin, in a statement. We curated these samples for the long term, so that scientists 50 years in the future could analyze them. Through Artemis, we hope to offer the same possibilities for a new generation of scientists.